Welcome to Keller's Coder, and today we'll be making a miniature, and the main takeaway for you guys is how to make realistic looking lava with Arduinos and NeoPixels. Motherfucker! So I like to create props every now and then, and since it's almost Halloween I wanted to make a little diorama called Gateway to Hell. I needed a little motivation to create some little tombstones in Blender and use my resin printer a bit more. I downloaded the model of the devil that I will incorporate in it. But the main takeaway for me was how to create realistic looking lava. I see a lot of people using epoxy resin and it's awesome, but it's not really realistic because it settles flat and it has a sheen on it. And lava isn't flat and has no sheen. So I figured, how can we do this? What do the big boys use? And I finally settled on something that is called a platinum silicone, a very soft silicone that is translucent. I dye it with a little yellow and then paint it with the reds and the blacks. And then we have a lot of fun with NeoPixels and Arduino coding. So that is something for you software nerds. Let's jump in. I start by cutting a piece of styrofoam to the size of the base. This baseboard will also cover the electronics because the electronics will be hidden inside of the styrofoam. I use a hot knife to cut the styrofoam, and here I lay out the diorama. It is a forced perspective that everything in the front is bigger than in the back, so that the stuff in the back in this case looks humongous. Here I use the hot knife to cut the lava trench, and this is one of the gates to hell. I didn't model this came from a Thingiverse. I did model the tombstones, and here I put wet clay on the base. The wet clay allows me to texture and sculpt the terrain. Here I use a texture stamp to make some of the road textures, which I will progressively make smaller with dabbing it with a styrofoam ball. And here the tombstones that I modeled and printed. And the tombstones in the front are far bigger than the tombstones in the back. It's about a 20%, 25% difference. And that gives that forced perspective look, making the devil seem even bigger and his gates humongous. Here I position the gates to see how I like them the best. And I finally settled on something like this. Yeah, we can look through the gates over the mountain range to the devil. And here I use that styrofoam ball to reduce the texture size of the path. And I had to wait until midnight until the clay was dry. Here I'm using EVA foam to make the pillars that hold the gate in place. I score them and give them the hot gun treatment so the scores open up and give it some texture. Here I paint all the things, and I settled for a palette of grays and brass-like oxide greens and some reds. And talking about reds, here's that little devil. Let's give him a red undercoat. And then I start to paint the details. Now I see many people really squeezing out that paint. You don't need a lot, even this is too much. Just a single drop can go at you a long way. Here's a single drop just for the teeth, which I was dreading, to be honest. But yeah, it worked out. And it gave him a nice Colgate smile. Now it's time to give him some eyebrows and some eyes. Here I use a black wash of acrylic that I'm dabbing off to fill in all the texture and make him look a bit weathered. After all, being in hell for about 2000 years, well, you soil up, right? I'm using some UV curing resin here to make the rocks more reflective. That way the light from the lava will reflect back more, making it seem to glow more. And here I'm pulling through a 3-strand wire for the NeoPixels. And here is the Arduino on a little perf board, and I put in a 7805 regulator so I can run it off 12 volts if I need to. And here I solder the Arduino into place. And here I solder the 3 wires to the NeoPixel. I stick the NeoPixel in the lava trench, just using its own adhesive tape. And now I'm closing off the trenches with some packaging tape to prevent the silicone from leaking out. Here I'm weighing out the silicone. This is a platinum silicone, a short 10, which is very, very malleable. It has the consistency of flesh, and I mainly use it for special effects makeup, like bullet holes, cuts, etc. Here I dye it yellow, just translucent yellow, just a single drop. And as you can see, it goes a long way, a single drop of this silicone pigment. It's really, really high pigment. Now I'll let it trickle into the trench and pull it away. I had some silicone left over, so I put it on my finger with some plaster bandage so I can make some more severed fingers from silicone. Here I pull off the tape and I pull off a lot of the paint. Oh bugger. Well, just put some black wash over it, dab it clean, and nobody sees the crime that was committed. I trim the silicone with the scissors to make it nice and flush. And I decloth my finger so I can make more of these sorts of fingers. Now I have 3 cups ready with silicone and 3 pigments. I use a black oil paint because I don't have black silicone pigment, and a red silicone pigment and a yellow silicone pigment. I dilute this silicone with naphtha, lighter fluid, benzene, however you want to call it, so that it's easy to brush on, otherwise it's just too thick. And I use about 5 grams of silicone and just as much naphtha. And here the red pigment, and here one with yellow pigment, and here one with the black oil paint. Oil paints work as silicone pigments. Not as well, but they do work. I first start to paint the darker yellow on the lighter yellow base, because lava goes from light yellow to darker yellow to orange to red to black. And that is what I'm simulating here. I'm making sure not to fill in the center, so that is nice bright yellow. Here I painted the reds. And now I paint the blacks. I just let it dribble in so you get these nice little ripples. I waited until the silicone started almost to set. And here we have it. And let's do a test light. It needs a bit more black, doesn't it? So I put more black in there. And also some stones. I just gathered some stones, dipped them in the silicone and put them on top. And that looks a lot better, a bit more contrast. That is what I wanted. And this is what it looks like in the dark. Just like Indiana Jones in a Temple of Doom, doesn't it? And the pulsating light effect, that is the NeoPixels that we will talk you through in a moment. So here's the code. It is all based around the Fast LED library. So you first need to install that with Tools, Manage Libraries, Fast LED, and install that. And that is all it takes. And this could be interesting as well. You can make matrix panels with these NeoPixel LEDs. I might do something in the future with that, but for now. The definition about the number of LEDs. I've got 16 LEDs in my project. What is it? 5 or 6 in the lava, and then 8 in the devil that lights the devil. And I still don't have the linear actuator in. It's been like 2 weeks, unbelievable. And it's a state engine. In the last episode we talked about state engines. This is also a typical candidate for a state engine. We have the 2 states currently, blending the lava colors and selecting lava colors. And there will be a third state, moving devil up and moving devil down, maybe 2 more states. And here I define the state. And this is my lava palette. I created a palette of different colors, reds, yellows and oranges, that makes up the different colors that we can have. And these are the most fitting for my project. And I will select one color randomly. I actually made 2 of these projects. We will run through the next one as well, that uses the gradient color of the fast LED library. So here we set the number of LEDs, so we said we had 16. And I create a second array, LEDs 2, with the same number of LEDs. The reason is that this is what is shown on the LED strip. And these are the colors that we're going to blend to. So we need the actual colors and the colors that we're going to blend to. Now this function sets the random lava colors in the LEDs 2 array for each of the lava LEDs. So I loop through the set of lava LEDs. And that is the I, that is also the index to my LEDs 2. From my lava LED palette, I will pick a random number between 0 and lava palette size -1. So one of these colors is assigned to that index of the LEDs 2. So for all the, what is it, A6 LEDs I believe, in the lava, we set a different random color and then we set the state to blending lava colors. So then the lava colors will change actually slowly to these values. And when they're at these values, we will go back to the select lava colors state, and this will be cooled again. These are 2 convenience methods to set the LED strips that illuminate the devil on the back of the mountain. Let's go to this, because this function is called from here. This is a fade toward color, so we get the current color, so that is the color in the LED, to the target color, that is the color in the corresponding index for the LEDs 2, and then the amount to blend by. I set this to 1, but you could expedite it by setting it to 5 or something, but of course then the values in the LEDs 2 and the LEDs current need to be a multiple that you actually can reach it. Here I call the step blend source to dest. By the way, this was some code that I found somebody else, I just refactored it a bit. So here we go to that. We take the current color and the target color and the amount again. If the current color is equal to the target color, then we're done. If the current color is smaller than the target color, we will create a delta. We subtract the delta with the Scale 8 video. That is a 8-bit color scaler in video space. It's really kind of cool. It's a fast LED function. And when I was researching how to blend, I came up with this example, except the names were different. And I saw this and had to look into it, what it meant, and that's fascinating though. Really cool. And the same here when we add the delta if we are smaller, and we subtract the delta if we're larger. So we're blending the colors together. And here is that actual method that calls the forward blend. So I set a flag, are the LEDs the same, to true. Then I cycle through the LEDs. If the LEDs showing are different than the LEDs 2, then we still need to blend forwards. Or blend towards, sorry, not specifically forwards. Could also be backwards. We adjust it and we set the flag to false, because then they're not the same. If they are all the same, then of course this flag is true. And then we return, depending on the state, select lava colors if are the LEDs the same is true, and otherwise we keep blending the colors. Here we set up the NeoPixels. I have a NeoPixel strip. Depending on your strip you have a different constant here. The data pin, I use pin 6 I believe, yeah, it was closest. And then your array of the LEDs and the number of the LEDs in that array. Here I set that color strip that illuminates the devil, that's a constant on, it's a yellow and a red. So I have a bit of contrast on his face. Here I initialize the lava LEDs with a random color from the palette, because otherwise it could be any other color, probably black. I don't want to start with black. And then we set the random colors into the LEDs too. And I set the state, and the state is blending the lava colors. So basically I'm priming the LEDs with a nice set of colors, and then we generate some random colors for the LEDs too, and we set the state to starting to blend, and then we get into the main loop. Well, of course we are still in the blending because we initialized it initially, so we start to blend the colors. And otherwise we select a color, and I only do that a random amount of time when the colors are the same, between 400 and 800 milliseconds. Now this is a cool convenience method that Fast LED introduces. I use if milliseconds greater than old milliseconds a lot to not block the microcontroller. And that's a lot of typing, and they just created a nice little macro for this. That was really cool. And I delay by 1 millisecond to have the blend at least some visual appeal, otherwise it goes too quickly. And then we show the strip. So then we're blending between colors like this. And you see the unpainted yellow translucency really pop through, and when the LED turns red, that yellow also turns red. So I'm really exploiting the silicone properties. Here is the gradient example. The code is very similar, because the main code is just the same. I just use a defined gradient pattern. So this means start at position 0 of the gradient. The gradient goes from 0 to 255. It's an 8-bit gradient. Set the color to yellow. On 63 set it to 3. So it basically blends between yellow and red in the steps 0 to 63. Then 64 we have a darker yellow, and again 127 we have a red, so we blend from darker yellow to red, and 255 we have a 0, so we blend from 127 to 255, from bright red to 0. So you have a more gradation in the colors of the LEDs that we set with the random lava color from palette. Now my palette is basically a defined gradient, and this again is a nice little macro from the Fast LED library, and you will see the rest is just the same. And that's the cool thing, if you have your code set up properly, it's easy to switch out things like this. Personally, I don't like this version very much. It could have its place, it's a matter of taste. It looks like this. I think it's a bit, it's too much of a hodgepodge of darkness in there, and this color palette is really balanced for my specific setup. And I think that is what makes it look so nice, is that you really only take those colors and you blend towards them that are actually fitting your scene, your lava. So my preferred method for this instance is this. But if you were to make, for example, a lantern or a candle using a gradient from a yellow to a red to a black, that would be great. So there it is. Nice glowing lava. So the main takeaway here is how to create fading NeoPixels. Take the code from the GitHub. You can also create this to create realistic looking fire on a single strip. You can of course segment it also, have different segments of colors that you will get a random and then fade in between that. The days are getting shorter again, it's almost Halloween, so get your hands dirty, create some gnarly looking ornaments. See you in the next one.